Today we're going to talk about x and y intercepts. That's your topic here. And really how to graph using those. So if graphing from slope-intercept form is too much for you, the M and the B, this is an alternate way to find the graph of a line or how to graph it. Okay, so the point at which the graph intersects the x-axis is called the x-intercept. You should know that. Here's our x-intercept at x equals -3. Or the x-intercept is at -3, 0, I should say. Okay, and then the point at which the graph intersects the y-axis is called the y-intercept. Okay, and so let's identify the y-intercept now on the graph. Okay, that's up here. 1, 2, 3, 4, and the xy coordinate of that point is at 0, 4. So if you notice, there's something that happens with an x-intercept and a y-intercept. For the x-intercept, the y is 0. For the y-intercept, the x is 0. Okay, so the opposite value is going to be 0, and we're going to use that in order to graph. Okay, and that will always happen. That's the definition of an intercept. All right. The x-intercept is also referred to as a 0, a root, or solution to the equation, especially when we're dealing with quadratics. You'll see roots and solutions a lot. Okay. All right, so finding them algebraically, finding the intercepts algebraically comes straight up from this graph here. Because if I have an x-intercept, the y is 0. If I have a y-intercept, the x is 0. Always. So we can do that and set the opposite one equal to 0 and solve for your x, okay? So if we're given an equation, to find the x-intercept of an equation, set y equal to 0 and solve for x. Same thing with the y-intercept. You want to let x equals 0 and solve for y. Then we're going to use those points and graph the equation, okay? Okay, so find the x and y intercepts of the equation y equals -2x plus 5. So if I have an x-intercept, let's let y be 0. Okay, so I'm going to write the equation again. Plus 5. And I'm going to plug in 0 where I see y. Okay, then you just solve for x. So if I minus 5, I'm at -5 equals -2x. If I have a -2 and 5 halves, or I mean you're graphing on the graph, so you probably want a decimal. 2.5 equals x. All right, so our x-intercept, we're going to put y is 0 and x is 2.5 together for our coordinate points. So our x-intercept is at 2.5, 0. Okay? And now our y-intercept, we're going to let the other one be 0. So y-intercept, let the opposite be 0. Okay, so where I see 2, -2, and then x, I'm going to put in 0. And that would just be y equals 5. Okay? So putting both of those together for a coordinate point, because we're still talking about points on a graph, the y-intercept is at 0, 5. Okay, and then you could just graph those 2 points and draw a line through them if you were asked to graph the equation, okay, which is what we're going to be asked next. So it's just taking one more step. We're going to find the x and y intercepts just like above, plot them on the graph, and then draw a line through them, maybe a positive or a negative line, but we'll see once we graph. Excuse me. Okay, so y equals, all right, let's do x-intercept, y equals 0. I'll write the whole thing out, okay? Then I'm going to plug in 0 where I see y. You can write the equation again if you want. Okay, solve for x. And you could write 1/5, but decimal-wise, that's 0.2 equals x. All right, so your x-intercept is at 0.20. Okay, because I put this x and that y together. All right, well, there's one of them. Let's do our y-intercept. So let x be 0. Okay, so y equals 5 times 0 plus 1. Y equals 1. So our y-intercept, putting both of these together, is at 0, 1. Okay, so now to graph this equation, we're going to plot those 2 points and draw a line through them. Okay, so 0.20 is just really right past 0. Right past 0, 0. Okay, that's my x-intercept. And your y-intercept is at 0, 1. Okay, so that is a very small line there. Okay, or very small space between the dots, but it's okay, you can still connect them. All right. And let's think about this. Did I do this all wrong for the y? I did. It's 5x minus 1. Hopefully you saw this. Oh, my bad. 0, negative 1. So ignore the green. And at 0, negative 1, this is the line here, okay. All right, my apologies. But that's why I always go and check my work. I saw that I wrote 2 different equations, so you should be doing that too. All right, and if I was to look at y equals mx plus b, it should look very similar. If I go to 5x minus 1, that's a b of negative 1 and a slope of 5. 5 over 1. Okay, well, that's not quite hitting very well. There. That should really be the line. And it will follow y equals mx plus b. So it's just another way to graph it. Okay. All right, number 2, let's do our x and y intercepts again. So x-intercept, and I'll try to get this one right this time. All right, so 0 equals negative 6 over 5, x plus 2. I'm going to subtract 2. Negative 2 equals negative 6 over 5x. Okay, and you could times by 5 and divide by negative 6. You can make that a decimal, whatever makes sense to you. I like taking 2 steps because I'm just used to students who don't always know how to multiply by a reciprocal correctly, even though I'm sure you guys do. That's awesome. Okay, and again, since I'm graphing on like a number line, I want to do 10 over 6 and find the decimal. So negative 10 divided by negative 6 is 1.67. Okay, so that xy coordinate is going to be at 1.67 comma 0. And you can do that if you're rounding for graphing. Okay. So, now y-intercept, x equals 0. Okay, this one's going to be a lot easier to solve. So y equals negative 6 over 5, x plus 2. And if you completely understand slope-intercept form, hopefully you're knowing that this is the intercept anyway. Okay, so when I plug in 0 for x, y equals 2. That's my y-intercept. Okay, that's where the graph should start, even if you're doing it slope-intercept form way. Okay, So 0, 2 is my y-intercept, and then 1.67 is your x-intercept, so that's almost all the way to 2 for the x. Okay, I'm going to draw this down. I have a negative line with a negative slope. Okay, that looks good. And if we were to do negative 6 over 5 for the slope, awesome, it worked out good here. Okay, you can graph this line in slope-intercept form to check yourself, okay? Down 6 over 5 should hit the graph again. There we go, that was a very good example. Okay, now, obviously, if they're in slope-intercept form and you're asked to graph the line, you can just graph it in slope-intercept form using the b and using the m. Totally fine. Okay, however, if you look at some of these other examples, some of them are not in slope-intercept form. Okay, so I'm going to skip 3 for now so that we can see some standard form and how to graph those. So this is the easiest way to graph from standard form for most students. So you don't have to solve for y and then find the m and find the b. Okay, I'm going to do 4 and then I'm going to kind of show you a shortcut for 5. All right, so for 4, x-intercept y equals 0. So 4x minus y equals 8. 4x minus 0 equals 8. 4x equals 8. X equals 2. Okay, so our x-intercept is at 2, 0. That was very simple from standard form. All right, so 4x minus y equals 8. Y-intercept, x equals 0. So I'm going to do 4 times 0 minus y equals 8. That's negative y equals 8. Y equals negative 8. Okay, so then this intercept point will be at 0, negative 8. Okay, much easier than solving for y and doing y equals mx plus b. So our x-intercept is at 2, and our y-intercept is at 0, negative 8. All right, connect your points. This way you are only gonna have 2 points for the line, but as long as you solve them right, it should work out good. All right, so number 5, I'm going to show you the way, kind of like the shortcut. So when we're plugging in 0, what really happens is that variable and whatever coefficients it has just goes away, right? Like if I covered up y and then whatever coefficient is with it, so the negative, if I covered that up, all that'd be left is 4x and 8, right? And then look over here, if I covered up the x, all that'd be left is the coefficient with y and the 8. So that's kind of the shortcut. Whenever you're plugging in 0, your other variable just goes away. All right, so for the x-intercept, I'm literally going to cross out y. So I'm going to write the equation again. And I'm going to cross out y and whatever coefficient is with it, because literally that's what happens when you plug in 0. Okay, so let's divide by negative 5. And then it just becomes an easy one-step equation as long as it's in standard form. So that's 4.8. Okay, so the x-intercept is 4.80. Okay, so let's try the y-intercept the same way, but this time I'm going to definitely write the equation again. So negative 5x minus 4y equals negative 24. And then I'm going to cross out the other variable and whatever coefficient is with it, because that's what would happen if we plugged in 0. Then I just have to divide. So y equals 6. 0, 6. Okay? And we can solve 6 and 7
the same way because they're both, well, they're not standard form, but they're solvable that way. Okay, so x-intercept is 4.80, 3, 4, 5, so right before 5, and then 0, 6, 1, 2, 3, 4, 5, 6. All right. And so if you didn't have this method, you would have to solve for y and graph y equals mx plus b. This is much faster, for me at least, okay? All right, so 6, this is not standard form, but we can solve it using the same idea. So for x-intercept, I'm going to cross out y and whatever coefficient is with it, okay? So then I just times by 4 on both sides. 3x equals -8, divided by 3. X equals -8 thirds. .67. Okay, so we're at 2.670 for our x-intercept. Okay, and then y-intercept, I'm going to write the equation again, just so I make sure I copy it right. And then I'm going to cross out, or scribble out, the x term. Obviously, if you have an eraser, you can erase it out. Okay, then I'm going to times both sides by 3. -1y equals -6. Y equals 6. Okay, so this is 0, 6 for my other intercept. All right, put those two together, draw your line. All right, so x is at 2.67 and y is at 6. There we go. Okay, last one. Let's do the same thing. Same thing here. So, x-intercept. We're going to scribble out y. Especially if you see something like this. That would be really hard to solve for y, or way more steps than if you just do it this way. So x equals 2.4. 2.4 is 0 is my first point. Okay, next. So y-intercept, we're going to scribble out x. You're always scribbling out the opposite variable. Okay, so cancel. Cancel those, so times by 6 on both sides. Divided by 5. .2. Okay. All right. So plot those 2 points. 2.40 is almost 2.5 for the x-intercept, and then 7.2 for the y-intercept. Right above 7. All right, that's how you graph from x and y intercepts.